talking about velocity time graphs, right? So something you have to remember is that the analysis for a velocity time graph is different than it is for a position versus time graph, okay? So again, before we look at the questions, I know what the questions are going to ask, but I want to break this down before we even go over there, okay? One thing I do want to point out, you may not be able to see it on your screen, but our units for time are minutes. That's okay, because we're just going to get a weird unit if we find an acceleration, okay, or a position. Okay, it's not going to be crazy. It's just going to be it's going to just talk about meters per minute squared, which technically is an acceleration because it's length over time squared, and that's fine. Okay, but before we get to those questions, let's look at our graph. Let's analyze this graph before we do that. Okay, so we know that we're going to have accelerated motion. We're going to have turning points, right? We're going to have we have one section of constant velocity. So let's point that out. Right there is our constant velocity, right? Remember, flat lines on position time graphs, or excuse me, on velocity time graphs are constant velocity. We have a positive acceleration here, right? We'll put Excel. We have a negative acceleration at this point, right? And over here we have another positive acceleration. Now I do want to show you something. If you look at, let me do a different color. So here in this section, it's above the line, right? Here in this section, it's sorry, not above the, it's above the axis in that first area, in this kind of shape, and then here you've got a below. Sometimes teachers kind of teach to break that up into two segments, right? So you would kind of look at, like, this is one timing segment for that, and that's another segment. And that's going to be helpful. That kind of thinking is helpful when you do a displacement calculation here, which is actually the top of the next page, because when you do the area under the curve, the axis is the stopping point, okay? So here, it's not a big triangle that looks like this or like this. It's here, right? It goes from curve to axis. So if I'm doing a displacement calculation for that segment there in the middle, right, the negative acceleration segment, I have to break it up into a triangle that's on the positive side and a triangle that's on the negative side. So let me do my time intervals again, where things happen. I'll break it up in two segments so we can just remind ourselves of that. So we have a positive A, we have A equal to 0, right? Not at rest, but A equal to 0. We have a negative A, positive A. Okay, even though this part is below the x-axis, it is a positive acceleration because that is a positive slope. Now, are there any points of rest? Yes. Here, here, and here, right? So I'll put them on our little timeline, right? And how do we know that those are rest? Because it hits the axis. And now, does it mean that it rests for a long time? No, it's a turning point for us on these graphs, okay? So there's just kind of our analysis now. If I want to break up into my segments already, right, for a potential displacement calculation, I've got one area, two areas, 3, 4, 5 areas that I'm going to potentially have to calculate. So I got 4 triangles and a rectangle. All right, so let's go and look at our questions. Does the object ever come to rest? If it does, at what time or time intervals? So they throw this in here, right, just to try to throw you off. These are instant times. These are not time intervals. And so if this is a multiple choice question, it would be like, 1 second, 2 seconds, 2 to 4 seconds, 5 to 6 seconds, or something like that. And to show the interval, would it have to be on the axis, right? It would have to, the line would be a flat line on the axis. But here you can see we've got 0 minutes, 30 minutes, and 55 minutes. Right? So 0 minutes, 30 minutes, and 55 minutes would be where we're at rest. Okay? And that's because it hits the axis. Right? Remember, rest on a velocity time graph means it hits the axis. All right, part B, what time interval or intervals is the object experiencing a positive acceleration? Well, we have two. If we look at our timeline, we go from 0 to 10 minutes and from 40 to 55 minutes. Oh, I'll put an M, N. Again, I work at numbers, not letters and sentences. Okay, so there's our two areas of, or two segments of positive acceleration. And then at what time interval or intervals is the object experiencing a negative acceleration? And then what is that negative acceleration? Now I split it up. Remember, this is where I've split it up, but you can just say it's one giant interval, right? From 15 seconds to 40 seconds. Or sorry, minutes, because our unit's in minutes. But if you put 2 down, that wouldn't be wrong. But when you find the slope, it's one continual line. So you're going to find the slope of that continual line. So it's our change in velocity over our change in time. So we're going to, our final velocity is negative 40 meters per minute. Our initial velocity is positive 60 meters per minute. And then our time is our time interval, which is 40 minus 15. So this tells us it's negative 100 over 25, or negative 4 meters per minute squared. Okay. Now, technically, yes, this is a weird unit, but it is a unit of acceleration. Okay. All right. Now, part D in this question says, what is the displacement of the object? And I'm going to kind of try to get it arranged so that we can see the graph as well as do the question. Okay. So I have to do. That's not bad. There we go. So I have to do 5 areas. So I have to do area 1, area 2, area 3. Now these are on the positive side. Okay. Then I have to do area 4 and area 5, but these are on the negative side. Okay. And so when we plug in our height into 4 and 5, we're going to plug in negative numbers. Okay. So because remember, we're looking for a displacement, so we have to include the direction. All right, so area 1 is a triangle, so it's 1/2 base times height, and that's going to equal 1/2 times 10. Our base is 10, and our base is 60. So that's going to be positive 300 meters. Okay, so that's our displacement from 0 to 10. And now from 10 to 15, it is a rectangle. So I'm going to do base times height. So I'm going to do 60 times 5, right? Because it's this area right here. It's only a 5-minute gap. And so that's also positive 300 meters. So you can see so for the first 2 segments, they've traveled a total of 600 meters, still in the positive direction. Area 3 is a triangle, so 1/2 base times height. Okay, and so my base is 15 to 30, so 15, and my height is 60. So, I got a lot of weird things. Now, eraser, erase that. I apologize. Back to my pen. All right, so I got 1/2. That was 15 times 60, and that's positive 450 meters. Okay, now I've crossed, I've stopped, now I've turned around, and now I'm going in the negative direction. Okay, so I have a triangle there, so 1/2 base times height, and so it's 1/2 our base of 10 minutes. Now this is where it's different, because now we're on the negative side. Our height is actually negative 40, right? Which is going to end up being negative 200 meters. So if you want to kind of sum these, I traveled positively 1,050 meters. Okay, now I'm going to figure out how much did I come back. Okay, and so now I do area 5, which is another triangle, 1/2 base times height. So I come up here, I have a base of 15, and I have another, the height is still negative 40, okay, and that ends up being negative 300 meters, okay. So let me hand this up a little bit, because now I've worked out everything. I don't need to worry about the graph anymore. I look at the graph. So that means that I've gone negative, come back 500 meters. So now to find my displacement, I would do my positive value. Really, I add, right, my negative value. Right, which gives me a total displacement of 550 meters in a positive direction. Okay, so that is the displacement of the object. It goes up to 1,050 meters, but then it comes back to 500 meters, right? Or it comes back 500 meters, so that's why our, it's negative 500. But starting from its initial position, it displaced itself 550 meters. Now, there could be a part E, right? If you want to do a part E on the fly, what is the average velocity for this trip? Right? Well, all you have to do is do 550 meters and divide it by 55 minutes, and that'll give you the average velocity to be positive 10 meters per minute. Right? That could be just a bonus question, or not a bonus question, but that could be like a part E. Right? What is the average velocity of this object? Okay. Now, in the next video, we'll do kinematics equations.